right, we've done sine, cosine, inverse functions, so let's do inverse tangent. If you remember, this is what the tangent function looked like. So this one's pretty easy to restrict. We just take one of these functions, right? And so that's what we end up doing. We restrict between negative pi over 2 and pi over 2. So kind of nice because it's the same domain as the sine, so you don't have to remember a different domain. And then, of course, drawing my graph. So if here is my tangent and reversing my x and y's, I get my inverse function. And my domain becomes what my range was of my tangent function. So negative infinity to infinity. And then my range becomes what my domain was of my restricted domain tangent function. I'm losing my voice. It's probably a good thing, right? All right, so I want to find the angle where the tangent equals 1. And I need to be sure that it's in this domain. And that should be an easy one because we always remember the square root of 2 over 2 are the same here. And remember tangent, sine divided by cosine. But look at this next one. Negative square roots of 3. Is it in this domain? The value that I'm looking for. Well, the problem is I have to check every one of these, right? Well, I know it can't be any of these because my tangent is sine over cosine, and all of these will be positive values. So I only have to check these here, and I know it can't be the 1, 0 or the 0, negative 1, and I know it can't be this one. So I just have these two to check. And so that's what I do, is I check this negative square roots of 3 over 2, where that's my y, and then 1/2. So if I do my sine over cosine and I divide those, I do see that that gives me my negative square roots of 3. Now, I knew a student once that they would write out the tangent values. That way, just very quickly, you could find that value. And so remember, you can't say 5 pi over 3 because you have to be sure that you're in the correct domain of negative pi over 2 and pi over 2. And so in this case, what we do is we just turn this into a negative angle. All right. And what I tend to do is I just look at these values up here and see that if I go straight down and across, so this next one would be pi over 4, but these are the negative of those angles. Have our same inverse properties, that if you take the inverse and then the function, you get your input back. So same thing here. If I notice this one, if I want to find tangent inverse of tangent of 4 pi over 5, I have to figure out where 4 pi over 5 is. As I mentioned to you before, I kind of like looking at pi, and that would be 5 pi over 5, right? Getting a common denominator. So 4 pi, that's probably a little high. 4 pi over 5 is somewhere in this quadrant, which is in the wrong quadrant. So what I do is I move it straight across, in this case by taking and subtracting pi. And so if I take 4 pi over 5 and I subtract pi, well, of course, I've got to get a common denominator, and that's where you'll see how I get my answer of negative pi over 5. So if you remembered with sine, we only had to move the y value, and we did that by taking pi minus this value. Well, in this case, as you can see, we're moving both the x and the y, okay, over here to this quadrant, and we do so by taking this value minus pi. If I'm looking up here, I see as long as that value is between negative infinity and infinity, it's all good. So it's good, right? So I just use that answer. And so that's the inverse for tangents. Now, what we're going to do is kind of go back to when you learned, didn't mean to do that. Isn't that awesome? We're going to go back to when you learned how to find inverses. So just a review that, remember, the very first thing you do when you find an inverse is you switch your variables. So no different, even though we have trig functions, and then you solve for y. Well, probably what I could do is add 1 to both sides. And so that gets rid of that. Then I could divide by 2. So I end up with x plus 1 over 2 equals sine of y. However, I want to solve this for y. Well, if you've been watching the last lectures, we know that if I take sine inverse of this, that gives me y. And so this simply is my inverse function. All right, and typically you'll see it written as sine inverse of x. All right, now if I'm asked for this function to find the range, okay, so for the same function, well, once again, I go through and I solve this. So I put it in terms of just sine, so y plus 1 over 2 equals sine of x. So I just move the 1 to the other side. And then I remember that the sine, let's put this where we want to put it, over here, that the range of the sine is between -1 and 1. You hopefully are remembering that. So I just simply put that in this range. So y plus 1 over 2 and then 1. And now I can solve this for y, my inequality. So I can multiply everything by 2. So I just have y plus 1 here in the middle. And then I can subtract 1 from every piece. And I get -3 y 1. And so I can say that, let's go up here, my domain of sine inverse is the same as the range, don't know how that happened, same as the range of sine, which we found to be -3 and 1. And then the range of my sine inverse is the same as the domain of the sine. And remember, when we're dealing with inverses, this is our restricted domain, so that becomes -π/2 and π/2. All right, so if you're asked to find the range of either function, the inverse or the actual function, don't forget this whole deal about the domain of the inverse becomes the range of the function, the range of the inverse becomes the domain of the function. All right, let's look at this one. So if I want to solve something like this, I could first divide by 3. So all I did was take and divide both sides by 3 to solve this equation. Again, remembering, if I take the sine of sine inverse, that gives me x, right? And you do something to one side, you darn sure better do it to the other side. And then you look up in your unit circle, and what's the sine of π/3? Anybody? So we should get square root of 3/2. So that's solving inverses, finding domain range, and then actually solving an equation that contains an inverse, and that ends the section.